We're going to be looking at proportional reasoning, and the method we're going to use to solve this question is algebraic reasoning. The overall expectation is to solve problems involving proportional reasoning, and the specific expectation, solve for the unknown value in a proportion using a variety of methods. In this case, like we said, algebraic reasoning. Let's look at our inquiry-based question. Whenever we have a word problem, it's good to read through it once, then read through it a second time and highlight what's important. On a sunny day, a flagpole that is 6 meters tall casts a shadow that is 2.4 meters long. At the same time, a tree beside the flagpole casts a shadow that is 4 meters long. How tall is the tree? Okay, let's highlight. On a sunny day, a flagpole is 6 meters tall, okay, and that flagpole casts a shadow that is 2.4 meters long. That's our first part of information. I'll highlight tree information in green. At the same time, there is a tree that is beside the flagpole, and it casts a shadow that is 4 meters long. The question's asking us how tall is our tree. So let's represent this relationship. First, let's build our tree here. Okay, so this line is going to represent our tree, and this will be the shadow coming off of the tree. And then what we'll do is we'll do the flagpole. The flagpole will be a little shorter, and the reason I know that is because the shadow of the flagpole is a little shorter than the shadow of the tree, which would mean the tree's height must be taller, assuming everything else is the same. So the height of the tree, how tall is that tree? That's our unknown. The length of its shadow was 4 meters. The height of the flagpole was 6 meters. And the length of the flagpole shadow was 2.4 meters. Okay, so we said we're going to use some algebraic reasoning. What we're going to do, we're going to set some variables equal. And I know I've written an x here. It's really representing just what's our unknown. So I'm actually going to take away the x because I'm going to use x and y as variables. So the height of the tree is unknown. Okay, sometimes they'll use let statements, so we'll say let x equal. We're not quite sure what we want to equal yet. A lot of times, x represents our independent variable. Okay, so if we look at this, we kind of have two variables. There's the height of something and the length of a shadow. The height of something and the length of a shadow. Okay, maybe setting up a kind of a chart here will help us out. Flagpole, and build almost a chart, and tree. And those are our columns, and our rows will be the height and the shadow length. Okay, let's write our info this way. Flagpole height, 6 meters. Flagpole shadow, 2.4 meters. Tree height, unknown. Tree shadow, 4 meters. Great. Okay. It makes sense that our heights, okay, are our independent. Okay, height is our independent. And our shadow is our dependent. And what we mean by that is that as the height changes, the shadow would also change, right? The shadow length is not going to affect the height of something. That could just be the sun in a different place in the sky. So our independence is what we usually call our x variable. So this will be our x, which works out really good because our unknown here. And our shadow will be our dependent. That'll be our y information here. Okay. Now what we need to do is we need to figure out a scale for this. We need to figure out what rate this is increasing by. Okay. And the way we're going to do that is we're going to use the information in our flagpole here. We use our flagpole information. Our flagpole information, we're going to take it and divide them. So what we mean by that is first we have to discover what kind of relationship we have. And you'll see there's two zeros here now. This is a directly proportional relationship, which means if the height is 0, then the shadow must be 0, which means we're going to be using an equation y equals m times x. Okay? And our m is our rate. So we have to figure out what our rate is. Now we said x was our independent. And our independent is being multiplied by our m to get to our y, which is our dependent, which was the shadow length. Well, the flagpole's got all that info from us. If this is our x, remember, height being our x's and shadow being our y, what's our rate? What is x being multiplied by? Okay, and in order to figure that out, Okay, we're going to take our, we'll take our 6 and we will divide it into our 2.4. So one way of looking at it is take, if we're using an arrow to get somewhere, take our ending value divided by our starting value. Okay, so our ending was our 2.4, and we divide it by 6, and this will give us our rate here, 2.4 divided by 6. 2.4 divided 6 gives us 0.4. Okay, so our m, in this case, all these things are equal, is 0.4. So y is equal to m, which is 0.4 times x. Well, we know our dependent variable in the tree's case, it's 4. So we're going to replace y with the value of 4. So 4 is equal to 0.4 times x. And the goal is to figure out our x. Well, we'll need to divide both sides by 0.4. And when we divide both sides by 0.4, this side reduces to a value of 1. Sometimes they call it canceling out. But essentially, you'll be left with an x on this side. And 4 divided by 0.4. If you take your calculator, you can try it out, the value will be actually 10. Okay, so we've just figured out that the height of the tree, because that was our x, was 10. Now, I'm going to quickly show you something. Say you set that up backwards by accident, and maybe you called your tree your y. Okay, so say you did it like this. Maybe you did y equals, you set up your equation, m times x, that's great, but you said that y was going height instead. Remember, we had y as the shadow before, and x was your shadow. Okay, well, if we do that, we just have to use the opposite rate. We'd be going from shadow to height, right? We'd be taking our shadow, multiplying by some rate. This is our rate here. So we have to figure out what that rate is. And again, we can do the same thing. Take our end value with our arrow and divide by our start. Okay, and our end was 6 and divide by 2.4. You can use a calculator, but this value actually ends up being 2.5. So we can rewrite this. You can check with your calculator and make sure that's right if you like. 2.5 times x. Okay. Now, because you called x your shadow, the tree shadow was 4, so we will be replacing, okay, I'll do it in red, the x with the value of 4 instead. And with our different rate, we should still come to the same answer. So 2.5 times our value of 4. You can use your calculator again. Okay. 4 times 2.5, and lo and behold, you get y is equal to 10. So no matter what you called your height or your shadow, your x and your y, as long as you set up the same rate here with your algebraic reasoning, you'll end up at the same answer. If you'd like to see other methods for solving this question, you check out our other playlists on proportional reasoning.